Welcome everyone to our Sporlan Experts webinar on the innovations around CO2 systems. We're thrilled to have you join us today and explore how Sporlan offerings optimize refrigeration equipment. As we go through the presentation, the chat function will be disabled, so communication will be through the Q&A screen only. We encourage you to submit your questions there and we'll address them during the designated Q&A segments. Before we dive in, I'd like to introduce our presenters. Matt Wood, our Applications Engineering Manager, will guide us through some of the features and benefits of the Sporlan CO2 refrigeration controls, components, and optimization. Matt has a Bachelor of Science in Engineering from the University of Missouri, Science and Technology. We're also joined by Joe Freese, who will share insights into the product features that our customers have been eagerly awaiting. Joe is currently the product manager of electric valves, ball valves, zoom lock, and other products. Joe holds a Bachelor of Science in Mechanical Engineering from the University of Missouri at Columbia and has been employed at Sporlan for more than 18 years. Additionally, all attendees to today's presentation will receive a follow-up email after the webinar containing the resources and materials that are presented today. So now, without further ado, let's get started. Gentlemen, the floor is yours.
All right. Thanks, John. Hey, good morning, everyone. Welcome to this webinar brought to you by Parker Sporlan. Today, we will be talking about CO2 refrigeration components and controls. This introductory presentation will be followed up by additional webinars going into greater detail in future CO2 and refrigeration products. My name is Joe Freese. As John said, I'm a senior product manager here at Sporlan. I've been here at Sporlan for 18 years, starting my career in design engineering. I've been a product manager for the past 4 years, my primary focus being electric and solenoid valve product lines. Joining me today is Matt Wood, our application engineering manager. Say hi. Hi, Matt.
Hi, Matt. As Joe said, I'm Matt Wood, our application engineering manager, and John introduced us earlier. Just a little more info. I've been here at Sporlan for around 13 years, started as well in design engineering, moved through product management, and now hold the role of applications engineering manager.
All right, so you heard at the very beginning, that was John Hoffman, our communications director. He's the one making sure this webinar runs smoothly, so thanks, John, for all the help there. All right, so grocery stores and supermarket are essential to everyday life. There are approximately about 50,000 supermarkets in the U.S. today, with more and more stores added every single day. Right now is a very transitional period in supermarket refrigeration, with many of the new installations using transcritical CO2. The rate of CO2 use and adoption is increasing every year. As basically right now, there's only about 3,500 CO2 installations in the US. For reference, Europe has about 55,000, so significantly more. They've started many years before us, and they're a little ahead of the game. But that's kind of the trend you see the industry going.
Yeah, the EPA has throughout the years passed legislation to protect the environment, and one such requirement is the restriction of use of refrigerants that contain harmful global warming potential chemicals. CO2 is a natural refrigerant that's always around us. It has a GWP of what?
1, Matt.
1. That's pretty low. Other refrigerant options exist, mainly A2L refrigerants, but these are just below the current limits. And there are risks that the limits would again change at some point in the future. This is similar to what happened with R22.
Hey, Matt, I always hear about reducing carbon footprint and all this stuff. Why do I want to use CO2 or carbon dioxide as my refrigerant? That doesn't make sense.
It's a great question, Joe. Even though we want to reduce our CO2 emissions, CO2 has around 500 to 1,000 times less global warming potential than current refrigerants in use today. Supermarkets typically have a total HFC charge of around 2,500 pounds. With CO2, they're able to drastically reduce that charge to around 600 pounds or so.
Well, that's quite a bit less.
Quite a bit. So not only does CO2 have a much lower GWP, but there's significantly less of it required to run the system. Advantages of the CO2 systems are fast pull down and stable temperature control, and this is a result of the high heat transfer coefficients of CO2. Small pipe diameters are also achievable due to that high capacity. Now we're going to consider CO2 as a refrigerant, or R744 as our industry calls it. It can be used in the system while reducing charge, as we said before, but unfortunately, there's a penalty to pay, and that's higher pressures. CO2 refrigerant pressures are significantly higher than other refrigerants. You can see on the chart that we're showing, CO2 operates around 200 psi for low temp and 400 psi for medium temperature. While in subcritical operation, you'll either typically have a liquid overfeed or a cascade system. Liquid overfeed would be pumping to circulate liquid throughout the display cases on the display floor, and the cascade would use compressors to produce the desired saturated suction and reject heat to the DX high side rack. Today, we're going to primarily focus, though, on transcritical CO2.
All right. Before we get started, kind of got to briefly go over what a CO2 system is. So on the screen here is our basic vapor compression refrigeration cycle. It has basically four main components in it. It has a compressor, evaporator, condenser, and most important, the metering device, or EEV, TEV.
Not a TXV, right?
Definitely not a TXV, TEV. Almost anything that cools, refrigerator, air conditioner, anything like that, has these four basic components. Now we're going to show you a typical transcritical CO2 system.
Wow, that escalated quickly.
It did. I mean, there's a lot of components on there, but while it looks complex, it basically boils down to the same four components, especially when we get into a subcritical operation.
What do you mean subcritical operation?
So subcritical is when CO2 is below the critical point of 87.9 degrees Fahrenheit. Below this temperature, CO2 acts basically just like every other common refrigerant in the market. Above this temperature, however, CO2 exists in an undefined state. It is neither a liquid or a gas. CO2 will cool but not condense. We're going to break down all these sections in much more detail further on in this webinar, and show how Sporlan is here to help with the components and controls in these sections. But first, we need to go over some of the differences between a standard direct expansion refrigeration system and one that is utilizing transcritical CO2.
So this is the transcritical CO2 pH diagram, or pressure enthalpy diagram. This can be a very helpful way of looking at what the refrigerant is doing throughout the cycle. So we'll start with the compressor. The CO2 is compressed up to, and then we get to above the critical point, depending upon the ambient temperature. From there, it goes to the gas cooler. The gas cooler acts very similar to the condenser in the common DX system. However, it's called the gas cooler, as you mentioned before, because it only cools the gas and there is no phase change. All you can do is sensible cooling and of the hot gas, and there's no latent heat transfer. It then goes through a high pressure or gas cooler valve. You'll hear them called both in the industry. That helps to maintain the pressure of the gas cooler condenser and to maximize the coefficient of performance in the system. The refrigerant flashes through the high pressure valve into the flash tank as a liquid vapor mixture, and then the liquid is then directed out to the cases, while the flash gas bypass valve will take care of the flash gas that occurs in the system.
Do all CO2 systems look like this?
No, this is just an example. There are many ways to do this. We're showing you just one typical example. In fact, this is such an important part of the system, the transcritical side, the high side with the gas cooler condenser, that we'll probably touch on a little bit more later in the presentation.
Thanks, Matt. All right, so one thing we know about CO2 is safety, right? Here at Parker, Sporlan safety is our top priority. We harp on it all the time. So we want to make sure we focus on safety. So one of the biggest concerns with CO2 is the increased pressure that it has. If liquid refrigerant is trapped in the heat exchanger and allowed to warm up to even ambient temperatures, the pressure goes pretty high. For example, CO2 gets to 80 degrees, which is just a warm, not even a hot summer day, right? If it's trapped, it will reach up to 950 psi.
Wow.
So in CO2 systems, there's pressure relief valves. So if you set those at different limits, depending on what the limit of the system is and what all the components are rated at, if the pressure exceeds that, it will expel the CO2 into the atmosphere. Well, stores don't like this happening because when it happens, now they're lost quite a bit of their charge in their system, right, to maintain that. Then they have to add more charge to the system, which is costly, have a service deck and all this. So in the picture on this diagram, it shows one of the ways that they do this. So, or to prevent this. So they will pipe check valves around the service ball valves in order to direct that back into the higher pressure parts of the system. As you can see on that, you see a standard ball valve with a check valve piped around it.
Wow, that looks like a lot of braze joints in the picture. Any idea how many?
Yeah, I think we counted this one. There's like 12, all done in the field. Probably, maybe, hopefully, with somebody purging nitrogen through it. Hopefully, not having any
We know
leaks.
everyone always does that.
Oh, always the case. So here at Parker Sporlan develop our EBV PR pressure relieving ball valve. So this can take place of the whole image in the picture, and with two braze joints, you can have a ball valve with the integrated pressure relief function into it. With these valves, you can simplify your system design while still ensuring proper safety protocols for servicing. These valves will allow any increased pressure in any service area to go back to a pressure relief valve or to the flash tank.
And it's an advantage that you would have this valve probably fully tested from the factory.
Yeah, this valve comes directly from the factory. It's already been leak tested. You know it's going to be secure, and with only those two field installed braze joints, pretty high confidence is going to work. So
now we want to focus on the compressor section of the refrigeration diagram. This section shows compound compression. The industry would refer to this as a booster system. Instead of having a heat exchanger like Cascade CO2 with direct expansion, this version directly feeds the low temperature discharge into the suction of the medium temperature compressors. This helps reduce the temperature difference and associated losses in the heat exchangers. Sporlan has been working on many new products for the high pressures of CO2 refrigeration. Some of those used in the compressor section are shown here. We have our sealed model oil filter that's rated for 90 bar, rated at 99% efficiency at removing 3 micron sized particulates. Pretty small.
Yeah, that's very small.
We offer that with a 3/8 inch flare SAE connection. We're also developing a replaceable oil filter. The MRP of that is 140 bar with 3/4 inch SAE port connections. That has that same 99% filtration efficiency for 3 micron particles.
So the next section we're going to kind of go over is the gas cooler section. So this is the one that Matt went over kind of in detail earlier. This is kind of the newfangled part of the CO2 transcritical system. So we're going to dive a little deeper in here. So kind of as a review of what Matt said earlier, this is the high temperature discharge gas is coming from the compressors that enter the gas cooler. The gas cooler simply rejects the heat to the ambient. Works just like a condenser in the standard system, but since CO2 is above the critical point, above 87 degrees, it will not condense. This is a sensible heat transfer process. The de-superheated gas leaves the gas cooler and expands through as it flows through the gas cooler valve. Liquid and vapor are then present and collect in the flash tank. The gas cooler valve regulates the gas cooler pressure, and then the flash gas bypass valves allows vapor to leave the flash tank and travel to the suction and the medium temperature compression stages. This helps regulate the flash tank pressure. Downstream, the flash tank CO2 pressures are subcritical and operate in a similar fashion as any HFC system. So we have two valves today. We have our gas cooler valve and our flash gas bypass valve. These valves are rated at 140 bar pressures, which is pretty high, right? So they're specifically designed for this application. That the gas cooler and flash gas bypass valves come in multiple sizes and fitting configurations. One of our new products that we just launched is our GCM valve, our gas cooler multi-purpose valve. This valve can be used as either a gas cooler, expansion, hot gas bypass, or just as a pressure regulating valve. This valve comes in smaller sizes than our current gas cooler valve. It also has an integrated motor head that you can actually use in the gas cooler valve. So you can take the motor from a gas GCM and place in the existing body on your system if you need a smaller size or something like that.
Does this valve have the mesh screens in them like the previous valve?
They all do. So you can take it out, clean it out, make sure it's nice and clean and ready to go. So the final section we're going to go over today is the refrigerated case section.
The magic happens.
Yeah, this is where everybody's quite familiar with where this is located in the supermarket. This is where all your frozen food, meat, deli items are stored. So This is an example of a common one. This one's showing multiple evaporators on the same system. Each evaporator could be used for a different case, controlling a different product. Could be frozen, could be, medium temp, anything like that. We have two primary options for expansion valves in our CO2 system. We have our SER-HP valve. This is one of our stepper motor valves. We have now recently re-rated or expanded our product offering to have 90 bar rated SER AA through SER B size valves. These operate with very tight resolution for optimal control. Additionally, we have our SPW or our pulse width modulating valve. This is basically a solenoid valve that rapidly opens and closes to control and acts as an expansion device. These valves will eliminate the need for additional liquid line solenoid valve in the system.
That's a good option.
Yeah. All these valves have very small ports for tight control. In order for these valves to work properly, you need proper filtration in the system. That is why we have just recently developed new 90 bar rated containment control system products for the side. We have our 90 bar sealed model today, and then we're on the verge of releasing our replaceable shell 90 bar valve filter today as well. And as well, you see in the slide, many of our EBVPR ball valves that we discussed earlier, these are used to help isolate this portion of the refrigeration system. So if there's any service required, and that
they have that integrated check feature.
That is correct. All right. Finally, in summary, here's a snapshot of our current CO2 portfolio of products available. Many of these products are new on the market, like I just talked about, the STR-BHP, STR-CHP, our GCM valve, the 90 bar sealed filter dryer. We also have a couple products coming soon, the replaceable shell and replaceable oil filter. And then we're always looking for new products. We're constantly in development. So I would definitely keep an eye out for future product development in the very near future as well to be added to this portfolio.
And Sporlan offers control solutions for these systems as well. We offer both standalone and full store systems. Our Microthermo branded products have been successfully used in over 700 transcritical CO2 installations in North America. With over a decade of experience in transcritical CO2 refrigeration, we've developed valuable control schemes for managing these systems. One of those pieces of expertise specifically is our hot gas defrost. We do a lot of that because a lot of our controls have been up in Canada, where that is employed a lot. These distributed control systems with dedicated hardware components are networked together for monitoring and communication.
Hey, Matt, what's all the orange lines on the screen?
It's a great question. Those would be the communication wires. And a lot of people who are familiar with more mechanical systems won't be familiar as much with a fully electronically controlled system. But that is something that will be different about most supermarket CO2 systems. You're going to see a lot more electronic controls, a lot more case controls, and with that, a lot more networking things that have to happen. For standalone applications, we offer the Sporlan S3C case controller. This is able to integrate with third-party supervisory controls, and it offers quick and easy ways to communicate with the controller, like our TechCheck mobile application that's available for iOS and Android. That app will let you analyze case performance, modify settings, troubleshoot issues directly from your mobile device. Now, when I say change settings, that'll be dependent upon the end user and how they want to lock down certain parameters or maybe not to. So this case controller has been installed also in many transcritical CO2 applications. Please look for future webinars if you're out there listening to us, specifically on the topic of controls, whether it's our Microthermo platform or our S3C case controller.
So that TechCheck app, is that something I can use to like troubleshoot, or like how detailed can I get in that?
That's a great question. As I said, it can be used for troubleshooting, but yes, it can be used. You can look, as you see here, the case display state of the app. You can see exactly what's happening with your refrigerated display case. You can then navigate to your alarm screen, and that'll give you a quick hit of what alarms are present on that case, and to give the technician an idea where they should concentrate. If they need to look at their expansion device, maybe their liquid line solenoid, they can also look at maybe temperature and pressures that are above alarm settings, and they can even graph different sensors and states of valves so that they can troubleshoot what's happened maybe the past 3 days, help them identify what the root of the problem really is.
So what happens if I can't solve the problem? Who do I call? Or
Ghostbusters.
All right, there you go.
No, you can call us at 888-920-6284. That would be our controls line. That line is manned both for our S3C and microthermo products. And you will get our team able to help you troubleshoot and walk through using those controls. For the S3C, we have some remote support capabilities as well. So if you call in and you just have the Tech Check app and no remote gateway allowing for us to get in a different way, we can go in through that Tech Check app and watch and see exactly what you're seeing. So if you're a seasoned veteran technician and you know all of the jargon in the industry, then that's a good tool for you to use on your own. If you have a newer technician that's learning the industry, we can actually see exactly what's on their screen and walk them through what the different parameters mean and give them ideas of what they might need to look for when they're trying to troubleshoot and solve problems.
All right. All right, so that pretty much concludes our webinar for today. One thing to note, if you do have any questions, primarily on our outside of our controls Matt kind of showed our MT and our S3C, any other of our other products, you can definitely contact us at 636-239-1111 to reach our tech support box here, and also the SVD tech support email is a great place to add. So I think we're going to open it up now to any questions. So I don't know, Matt, do you have the Q&A? See if there's any questions in the chat today?
Yeah, I got one question that's queued up for us. Will there be more webinars on CO2 controls in the future, Joe?
Yeah, I mean, we're planning on going much more in depth. So this is a pretty introductory level presentation today. We're planning on talking more about our S3C controller, or MT product offering, and also additionally any more other system deeper dive in each of these systems.
Absolutely. Our microthermo controls, which have decades of experience and a decade plus experience in specifically transcritical CO2 control, we're going to have specific webinars on that topic as well. Let's see if there are any other questions in the Q&A. And it looks like there aren't.
Well, I see some in mine. I don't know what you're looking at, Matt.
I don't know what I'm looking at either. Why don't you tell me what you see?
So I have somebody asking, what is the difference between MRP versus MOPD?
It's a great question. Maximum rated pressure is the MRP, and that would be the pressure that the valve as a pressure vessel is rated for. So if it's got an MRP of 90 bar, that valve in operation can see up to 90 bar. Whereas MOPD would be the maximum operating pressure differential. So that's the differential pressure that the valve can operate under. Above that, we can't guarantee the performance of the valve.
Okay, so that's the pressure from like the inlet to the outlet, usually of a valve, like a SCR valve. That's the difference in the pressure on the upper side, the bottom side. So if that goes too high, the valve might not open, right? If the inlet pressure exceeds the outlet by more than the MOPD setting.
Excellent. Yep.
All right. Another question, what is the bar rating of a single SAE flare in copper? I don't know the answer to that. Do you know that one, Matt?
Off the top of my head, for any of these questions we don't get to you on here, we'll connect with you offline to give you an answer. What's our next one?
All right. So this one's definitely going to be for you. Does the comm loop for the controls need to be a true daisy chain? The picture didn't show that.
So the picture showed our microthermo products, which do not need to be a daisy chain. Our microthermo products use a LANWorks communication protocol that you can have various schematics. For our S3C product, we do need a daisy chain. That's how those would be wired. They would use BACnet over BACnet with an Ethernet wiring, typically to wire case controller to case controller, and a lot of times they'll use RS-45 to go to the supervisory controller.
So another question was, can these valves be used with the newer press fit fittings? So most of our press fit fittings have a current pressure rating of 700 psi, maximum rated pressure. So most CO2 systems would exceed that, especially on the liquid line side or on the high pressure gas cooler version. So they are currently not used in CO2 systems basically for that reason. it is definitely something we are looking to address in the future. But as of today, that's the case today.
So I see another one in here. Will webinars be recorded and able to be shared with employees at another date, Joe?
I think every webinar is recorded.
Absolutely.
Yes. So,
and John's going to be taking care of that for us. So this webinar will be available later on. And one more question I see here. Does Sporlan have in-house tech support for microthermo, or do you have to call Canada? So just to in-house, I would call it in-house. So our Canada team members that work with our microthermo product are all still part of Sporlan. And in fact, our call center or dispatch for the S3C product still runs through Canada, and we dispatch it out that way. We have several second-level support individuals that are actually located in the United States. So it's not a clear answer, but yes, we support out of both Canada and the United States for microthermo. We do have an integration team located all over the United States that would be part of that next level technical support. Sometimes gets involved with more challenging calls.
All right. So Matt, one more question, you think, or
let's see.
All right, I have one here saying, can the GCM valves be used as more than just a gas cooler valve, such as a larger EAV for CO2? That absolutely. That is why they're the multi-purpose valve, right? So they can be used as a high pressure expansion valve, a hot gas bypass valve, just a pressure regulating valve, in addition to the gas cooler valve. So it's pretty much ideal for that type of application.
All right. Well, if we didn't get to your question, we'll take a look at these questions and make sure that we're able to get back to anybody that we weren't able to get to on here. With that, I think we'll end the webinar. Thank you, everybody, for joining.
Yep. All right. Thanks, everybody. Have a great rest of your day and have a great weekend.
Hey, just to jump in here, guys. I just wanted to thank everybody for being on the webinar today, and a big thanks to you, our presenters, Matt and Joe, for sharing your information with us. We really appreciate everybody's participation. We will have the videos available on our YouTube channel, and I just want to encourage everybody to keep an eye out for our social media channels for announcements and registration details on the next upcoming webinars. We're going to try and do these once a month. And make some information available to folks. You know, as the guy said, this was just a really shallow dive into some of the information. There'll be a follow-up email that's getting sent to everybody out that was registered for this event, and we will provide some additional information, some resources onto our CO2 products. We actually have a CO2 section on our website that has links to training videos, our online virtual engineer, different resources available. So be on the lookout for that. That should go out here in a couple of hours. So again, this session was recorded. We'll be on our YouTube channel. You can check it out, and our video shorts and the other training videos. So just want to say thanks again to everybody. Have a great day, and we'll catch you again next month.